What is up, Jaguar students? It is your friendly neighborhood math teacher, Mr. Allred, and we're here to talk about Unit 7. This is actually our last mini lesson in Unit 7. We're going to talk about the sides of triangles. We're going to talk about the sides of triangles and just some important, really one important key fact about the sides of triangles that's really important. Okay, what I'm going to do on this video is I'm going to tell you something about the sides of triangles, a rule. And when you come to me for your station, you're actually going to be able to investigate that and experiment with that a little bit. But for the sake of this video, I'm just going to tell you, okay? You'll be able to solve a problem just like this one at the end of the day. By the end of the day today, you should be able to solve a problem like that one, okay? Learning goal, you should be able to explain how to define and classify triangles, all right? And this first part of the note, we're going to be classifying triangles by their sides. It's important to know that a triangle has 3 sides, right? I would definitely write that down. There's 3 different ways you can classify a triangle by its side lengths, okay? If you're thinking about its side lengths and their relationships to each other. The first way is an isosceles triangle. That is a triangle that has 2 equal sides, and therefore it has 1 unequal side. An isosceles triangle usually looks just like this does, okay? And it's important to know that those 2 sides that I've put red lines are, those 2 sides would be equal. Those little lines just mean congruent. When I put 2 lines, 1 line on either side like that, that means they're congruent. An isosceles triangle has 2 equal sides, just like that one does in blue. Okay. There's another way to classify them. You can call them scalene. That's a triangle that has no equal sides. That doesn't mean it's bad. It just means it has no equal sides, much like this one right here does. This is a triangle with no equal sides. So this is a scalene triangle right here on the second part. The next thing that we talk about is an equilateral triangle. An equilateral triangle is a triangle that has 3 equal sides, much like this lovely triangle right here does, with these 3 congruent lines. This triangle has 3 equal sides, and it's called equilateral. Makes sense? Okay, that's really a 6th grade review. You should have heard those words before in 6th grade. Okay, and those are all valid triangles that have different side lengths. Okay, what we're going to do in part 2, you're going to investigate this a little bit more. When you come to me, we're going to play with straws a little bit. But what I'm going to tell you is I have 2 triangles and then 1 collection of side lengths that does not make a triangle. Okay, and I'll try to show you the truth about this rule and what the side lengths have to have. Okay, if you had 1 triangle that had the following side lengths, 8, 9, and 10, 8, 9, and 10 units or centimeters, whatever you want to call it. Okay, that you can definitely make a triangle with those side lengths. It would be scalene, but you can make a triangle with those side lengths. If you take the small side and add the medium side to it, you get 17 units. Okay, this is a triangle. This works. Fill this out with me. Triangle number 2 would have side lengths of 3, 4, and 5. You're just filling this in this chart. You don't really see these triangles. I just want you to write these numbers now. Okay, and if you add the small side and the medium side, you do get 7. 3 plus 4 is 7. 8 plus 9 is 17. Both of these 2 side lengths would create triangles. They make triangles. Okay, those work. They're all scalene, but they work as triangles. This next example is not a triangle. Okay, it is not a triangle because it has side lengths of 3, 6, and 9. Okay, it does not work because it has side lengths of 3, 6, and 9. When you add 3 and 6, the small side and the medium side, what do you get? The truth is, you get 9. Okay, what I'm telling you is that I know that those first 2 triangles work. You can make triangles with those side lengths. The third triangle does not work. I'm going to show you some more of this when you come to my station. Okay, but I want to compare the sum of the lengths of the small, medium size to the length of the large side. I want to look at these things. If you compare the first triangle, the small side and the medium side was 17 together, the large side was 10. The second triangle, the small side and the medium side was 7 together, and the large side was 5. But for the last one, the small side and the medium side added together was 9, and the large side was also 9. Okay, what did you notice about the one that didn't work? Pause your video, talk to a partner. Okay, the truth is the sum, what does sum mean? good people. Sum means add, addition. So when you add the lengths of the two smaller sides of a triangle, they must be larger than the length of the largest side. They must add up to be greater than the length of the largest side. If it is equal to, it will not work. You can't make a triangle that way. And I'll show you that when you come to my station. Can the side lengths below make a triangle? How do you know? The truth is that for this first triangle, you can take the two smaller sides. You can take 34 and 26 and add them together. And you get 60 when you do that. Because those two smaller sides add up to be bigger than the larger side, that means yes, you can make a triangle that way. But for instance, number 2, this second one, 12 plus 8 is 20. And the truth is that 20 is not bigger than 20. 20 is 20. So you actually cannot, no, you cannot make a triangle out of the side lengths for number 2. Okay, what we're going to do is you're going to rotate to me in just a little while when I'm done with this first group. Okay, and you'll see for real why that works the way it does. If you feel comfortable with that rule, you can look at the next 2 examples and you can look at some on the back. If you're still uncomfortable with it, then go work on your 10 marks assignment until you come to me. And then I think I can maybe prove some math to you when you come to me. Thanks for watching. Thanks for taking those notes. I tried to keep this video short for you. Please keep all hands and feet inside the ride. Stay classy. Don't be trashy. And of all my students that I've ever taught, you are one of them. You thought I was going to say something nice that time too, didn't you? Have a great day or not. Make it the choice. Make it. The choice is yours. Okay? Goodbye.